Okay, so there's one single feature in NATS JetStream that just blows away all of the competition. It isn't even fair. I'm talking Kafka, Pulsar, RabbitMQ, Redis. That feature is how NATS designs its consumers. And so today, I'm going to be walking you through all of the different settings for consumers, and we'll go through some practical examples and why their flexibility is really this superpower in NATS that when unlocked, it really makes your architectures a lot easier to deal with, and it removes a ton of upfront design cost. So let's get straight into it. Before we get into the video, I've been getting a lot of feedback from y'all that this content is super valuable, and so we want to make sure it gets out to as many people as possible. So be sure to share this video with a coworker, before you jump into this video. It's a great one, by the way. Do like and subscribe. All right, on to the video. So in previous episodes, we talked all about streams, and we talked about all the different ways we can configure it, and that streams are just a really cool data structure to be able to use to modify. And when you have an ordered set of messages, you could actually create and express a lot of different distributed systems patterns. And consumers are no different. In fact, I think consumers are a bit more flexible than streams themselves, and when combined, you can do a lot of really interesting things. But the best way that I like to describe consumers in NATS is that they're really windows into the data of the stream. And I don't mean, just basic windows like basic filtering and everything like that. Everybody's got some basic filtering in some way, shape, or form. But NATS JetStream kind of takes this to the next level where you can filter on the entire subject, and you could also have a lot of control over how your messages are delivered, how they're re-delivered, when you start, everything like that. To the point where, you can build pretty much an entire application on top of JetStream and consumers if you really wanted to. And I'll give a little bit of a preview as well into some of the newer features that are coming to NATS server that make this kind of use case even better. But let's start with some of the basics. So imagine that I have a stream up here, and my subject hierarchy looks like this. I have orders.location. This could be like US, EU, Canada, things like that. Then we have the order ID, and then we have the status. Now, this is really important because one thing to note is that something that sets kind of JetStream apart from a lot of the other alternatives is that JetStream does index on these topics, and it gives you a lot of kind of functionality for being able to filter and act on these different topics. And this is kind of the crux of where a lot of the flexibility in JetStream consumers comes from. So imagine that we have a stream with about 6 messages in it. So we have sequence 1, 2, 3, 4, 5, 6. And then we have 3 different kind of expressions of consumers. And these are just examples. To be honest, there are so many different ways that you can configure consumers, but I wanted to put together a couple archetypes that kind of made sense for a couple different applications. So let's imagine for a second that we have kind of an event sourcing consumer. One of the kind of core tenets around event sourcing is that we've kind of distributed how like data is stored in a way where we have maybe a centralized place where all of our events took place, like a log like this, and then we then project out our data into different kind of data stores so it's easier to get at, and people can, all of these things can interact and coordinate with each other in very interesting ways. And so imagine that we need to be able to take, all these messages and process them one by one. So, maybe we have a state machine on the other end that needs to act on those messages in a certain way. Maybe it's a workflow engine, stuff like that. And so this event sourcing consumer has a couple attributes to it. One, we probably want to filter or just say we want all of the orders. We, of course, want this to be durable. We want our acts to be explicit and our max act pending to 1. Now, if you don't know what any of that means, that's okay, because I'm going to explain what all these settings mean. Consequently, you can also express a consumer in a reporting style consumer. Maybe you want to answer a question like, hey, how many of the orders in the US shipped within the last hour or within the last 7 days. That normally is something that's reserved for like, a SQL query. But you can actually do this in NATS. You can go tell NATS JetStream to deliver you only the messages that qualify for that particular set of assumptions. And again, this is where NATS JetStream is super powerful, because the alternatives kind of just give you a fire hose of messages and expect you to filter them out on the client side, which that can work for a lot of use cases, but at a very high scale, that can be very extremely slow, and it's also just extremely inefficient. And so again, one of the superpowers is that you don't have to do that with NATS JetStream. You really can just have JetStream configured to send you exactly what you want to use. The third one I would kind of argue that is even more efficient with its data is kind of the lookup pattern. Maybe you have a particular resource, bound to this order ID, and you're like, just give me all of the events related to this one ID. And NATS does a fantastic job just filtering on those and giving them to you. So these use cases are all expressed by different settings inside of a NATS consumer. And today we're going to be jumping into all of those settings, and then we'll write each of these examples together. Don't worry, this will actually be pretty quick. So let's move on to our first kind of major concept of consumers, push versus pull. So we've recently kind of moved to more of a do almost everything in a pull-based consumer. It doesn't mean that we've completely deprecated push-based consumers, but we've found that in practice, pull-based consumers make things a lot easier to reason about. So let me explain to you the differences between the two. So a push consumer is a consumer that opens up an inbox and just gets messages sent to them, and they receive them and everything like that. That's great. But the NATS server will send those messages as fast as they possibly can, which makes things like control flow difficult, especially if you do have consumers that are kind of slow to consume. There is some control flow mechanisms and heartbeats and everything built into those push consumers, but they, it still gets a bit challenging to reason about flow control because it's not this kind of, synchronous, like I'm going to ask for more messages and then get them. In fact, it's just going to be sending you messages no matter what. And so it is a good fit for some things like monitoring and things that need to be as responsive as possible, as real time as possible. You could lean into this, but we've found better performance and better scalability within a pull-based consumer. So that's what we would recommend. On the other hand, the way a pull-based consumer works, instead of just getting messages sent down to it, it's going to make a request to the server saying, hey, I want messages or a batch of messages. I want to go fetch some messages. And the server will then resolve that, send the messages, and manage all that for you. And so that's why we recommend going to pull-based consumers. They're easier to horizontally scale. They give you a bit better flow control. And in the newer versions of the NATS JetStream SDK for all of our different clients, pull consumers are kind of the default under the hood, and you don't really have to mess too much with the fetch semantics. You can just pretend like it's a good old iterator or consumer or whatever kind of pattern that you're using inside of your language of choice. And so this is kind of your first option when you're creating a consumer. And I wanted to lay out why we kind of lean more towards pull consumers for this example. The next option that you're going to come across or concept is really like durable versus ephemeral. And this can be really confusing at first why we have this, because this doesn't really exist in a lot of other technologies, this idea of ephemerality inside of their consumers. But it's actually a really powerful concept. And in a couple of the use cases that I lay out where things are ad hoc, it leads to just better scalability overall, because you're not going to have to lean on a, permanent consumer that you're going to have to manage over the long life cycle. So a durable consumer is for long-lived consumers. If you're used to something like Apache Kafka or Pulsar or RabbitMQ, this is going to be your kind of bread and butter. I create a consumer. NATS kind of keeps track of where that consumer is at, what messages it's processed or been delivered to, what messages it's acknowledged, and which messages need to be redelivered. And so this durable consumer is there for long-lived consumers, and they usually must be deleted explicitly, but this is also changed in a recent version of NATS server. In 2.9, you can actually set inactive threshold, which was reserved for ephemeral for a long time, but now can apply to durable. So you can just have durable consumer with still an inactive threshold. An ephemeral consumer, on the other hand, is a consumer that's meant to be more ad hoc. It's something that you just create on the fly, and you can just leave alone. When you unsubscribe, there will be some sort of timeout or an activity threshold where then the server will clean that consumer up. So this is great if you're just doing basic operations, doing ad hoc queries, reporting, maybe anything to do with the browser where browser sessions themselves are ephemeral, so you don't want to keep them around. It's good for just spinning up. And the cool part about consumers is that they're very, very fast to spin up. They're very, very fast to create. And so with NATS, ephemeral consumers are actually possible to do in a very scalable way. And so we're going to be using kind of both of these models today in our examples. Next up is filtering. Again, this is part of the bread and butter of why JetStream consumers are just so freaking powerful, is we get to filter all of the messages before they go over the wire. In other technologies, especially Kafka and Kafka Streams, Kafka Streams gives you all this power in being able to kind of, map and reduce and select and filter all of these different messages, but all of that has to happen on the client side, meaning the broker itself, the Kafka broker itself, is going to send every single message over the wire. And so from an architectural standpoint, there's not a lot of incentive to have extremely large topics of a wide breadth of data, because it's not reasonable to send all of that data and filter them over on the client side. So there's a lot of upfront kind of design work that needs to happen in a situation like Kafka, where the size of your topics really matter, and because you're sending all of that stuff over the wire. This doesn't apply in JetStream, which is why when people kind of ask us, hey, should I create a bunch of different streams for this data set, or should I put it all in one stream? We usually recommend people try to consolidate a lot of things to one stream, because it's much easier to just filter out on the client side. It doesn't mean you go put all your data in one stream, but instead of having a orders shipped topic and an orders deliver topic like you normally would in Kafka, you can just have an orders topic and have all of the life cycle there at your fingertips, ready to filter on. And it makes it very, very easy to then get at that data in any way that you want. And so filter subjects are great for that. You can basically use your subject-based addressing to filter any way that you want and to use wildcards, and we're going to use this pretty heavily today. Storage is a minor one, but you can choose how you want your consumer to kind of be stored, whether you want it in memory or to inherit from whatever the stream has, whether it's file-based storage or things like that. Kind of related to that, very quickly, consumers are also replicated and have their own raft groups. And that's something to keep in mind as you're scaling out consumers, is that you can set a consumer to an R3, which will keep it very durable. And in the case of disaster recovery or even a node just kind of going down, it will still continue to operate, still even continue to operate with 2 nodes down in some very rare circumstances. But that's something to be thinking about as you're creating your consumers. Very much for ephemeral consumers, they're in memory and they are an R1, because ephemeral consumers don't really need to stick around for very long. And so this is where we start seeing some of the divergences between these design decisions and why it's so flexible to be able to create both durable, ephemeral, R1 to R3, in-memory, file-based consumers, and all of those things can coexist against a single stream, which is beautiful. All right, let's get into acknowledgements. So an acknowledgement is basically, a consumer being able, or a client being able to tell the server that this consumer has processed this message. They've received it or they've processed it. They've acknowledged that they've gotten it so that the cursor can continue to move on the server end with regards to that particular consumer. Now, there's a couple different policies that you can set for a consumer acknowledgement policy. You can set it to be explicit, which is the default, which means every single message, gets acknowledged like this. You go ack, 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 and those will just continue to move on. These ones are kind of pending, meaning that we'll talk about max ack pending in a little bit, but you'll have some messages that are sent out and are waiting to be acknowledged, but you'll kind of acknowledge messages one by one in an explicit acknowledgement policy. Then we have all, where we can take a group of things and we could just, receive all of these messages, and then we could say, yep, acknowledge, and it's going to acknowledge everything that it's sent since it's received its last acknowledgement. So this could be good for kind of like batch ingestion. But it's worth noting that these acknowledgements are all asynchronous. They're not going to be blocking necessarily unless you have kind of a max ack pending. You're going to be having non-blocking acks. So in general, it's good. It's generally better to just use explicit for a lot of reasons, but all could be good for some of those edge cases. And then we have the none ack policy, which can be good for things where you just want to YOLO and maybe you're doing some sort of reporting. It doesn't really matter that you get real acknowledgements that these things are delivered. You just want this to show up as fast as possible and be delivered like that. You can set an ack policy to none, and that will be your fastest option because you don't have to have round trip times back to the server. You just get your messages delivered to you, and you don't get any guarantees around that delivery, but that's okay because that might not be the use case that you're going for.
Let's move on to max Ack pending. This, is a mouthful, and it's sometimes hard to understand what it means. So when we are sending messages, to the client via a consumer, we can set kind of an upper bound for how many messages should the server be waiting on to receive acknowledgements. And so if we set a max Ack pending to 1, for example, let's say we've acknowledged 1 through 4, we have a max Ack pending of 1, which means the server is going to send number 5 and is not going to send number 6 until number 5 is acknowledged. And that's because we have 1 set for a max Ack pending. Now, if this was set to 2, it would send 5 and 6, and 7 would kind of be queued up. So by default, this is actually set to 100, which actually makes, out of the box, your JetStream consumers can really process a lot of things in real time very, very quickly. We can obviously set this to a lower number. One of the reasons you might want to set this to 1 as an example is if you really want that strict ordering. And we'll show that in one of our examples is how we achieve kind of that strict ordering. We don't process anything out of order. We get a lot of guarantees around it, but it's also very slow. So trade-offs here. We also have kind of an acknowledgement wait period, which is, when there are outstanding acknowledgements, how long should the server wait before it decides, hey, I'm going to start redelivering that message? And so by default, this is set to a reasonable setting, but you can set this and configure it to whatever you want. But just to kind of show you guys how it works, you have acknowledgements, that the messages that you've already acknowledged, and then you have 5 and 6 kind of out waiting for acknowledgement, and 5 might be on a timer, have 12 seconds left, where 6 might have just been delivered and has 30 seconds left. And so when these timers expire, the server has decided that whatever client, they sent that message to for the consumer is not going to continue processing the message and or has timed out or has had an issue, and so it's going to attempt a redelivery. Speaking of delivery, let's look at the delivery policy. The delivery policy kind of dictates how messages get delivered, and particularly, for the most part, where they start in the sequence. And so by default, we have a deliver policy of all, meaning that the consumer is going to start at the beginning of its sequence, and it's going to deliver all of the messages there. And so in this case, it's going to start at 1, and it's going to deliver 1, 2, 3, and 4, 5, 6, or somewhere in the future. They haven't actually materialized yet, but it's just going to continue to send things on into the future. Then we have the new deliver policy, which is only going to deliver new messages. So if 1, 2, and 3 are in the stream and qualify for the consumer, they're not going to be sent, but they are going to, start delivering any new messages that come along. And this is great for things that maybe need to jump in and just start seeing, they don't need to start at the beginning of the stream, but in fact, they just need to start, where data is coming now and maybe start inspecting stuff. Great for monitoring or ad hoc, ephemeral consumers. Then we have a variation on this, which is last, which is very similar to new, except it will just send you the very last one, which could be, again, be useful for debugging. It's just kind of a nice convenient way to not have to look up the last sequence and then pick that one. Then we can actually select by a starting sequence. So if you know kind of the message sequence for this, particular stream that you want to start on, you can pick that sequence and then just continue from there. And so in this case, if I do a start sequence of 3, that's going to deliver 3, and everything in the future. Then the last two are start time and last by subject. Start time is great because I can pick a time and say, I just want to start then, which can be great for ad hoc queries or reporting, where I might want to say, hey, yeah, give me like the stuff starting from the last 7 days or from an hour ago. And we could just, start our stuff there, and we won't have to start at the very beginning and, move all of those messages through. Lastly, and this is the more interesting one, is we have last by subject. So this is similar to last, but it's going to kind of deliver all of the last messages on a per subject basis, which could be really, really interesting. And it's kind of one of the core things that drives like our key value store, which, it will start delivering all of the last values known for a particular subject. So maybe if you're doing some sort of kind of change data capture, or where you might have like a, order.updated, and you have multiple of those, and really you only want to have the last one because that's going to give you the most up-to-date, information about that order. You can absolutely do that, and you're saying, give me all of the last updated events or messages from all of the orders. You can pull something like that off very, very easily with last by subject.
Okay, and now we get to our last one, which is our replay policy. And this one's super fun. It's a little bit of an edge case, but it's here if you need it, and it can be really fantastic for debugging. And so our consumer replay policy, by default, it's instant, meaning it's just going to deliver these messages kind of as fast as they can. It's not going to delay any messages for any reasons. Obviously, you have flow control on the consumer side that will dictate that, but for the most part, it's going to just try to deliver the messages, as fast as the consumers want them to. The original replay policy is going to actually hold some of the messages back, and it's going to create timings inside of in between each of these messages that are the same timings upon which they were received, which means that you're going to be able to kind of play back the messages in the same timings that that they were originally done in. So this is really great if you're like doing maybe click tracking on the web and you want to kind of replay all of that interaction in a live session, or maybe you want to, start from a place in the stream that was problematic and you want to just replay those events. Maybe you got a spike, or maybe you had some sort of anomaly. You can easily just create a consumer and start debugging it. And again, this is the really cool part about all of this is, debugging in production. I know that can be kind of a challenge in and of itself, but you can, with the fact that you can create as many consumers as you want in these crazy configurations, you can do all sorts of really interesting things by, just creating a ephemeral consumer, using it as a debug consumer, and starting to kind of inspect how things are working under the hood, without affecting, the stream, without having to reconfigure the stream in any way. The stream is the stream and the consumers are all the consumers, which is really, really neat. A couple more features. We have max delivery and Backoff. This all has to do with how we, configure how things get redelivered. And in a previous episode not too long ago, I covered everything related to job queues, priority queues, doing exponential Backoff and stuff like that. And so I'm not going to cover this too much in this video. If you want to check out more about max delivery and Backoff, go check out that video. There's a lot of cool practical examples there. And then some miscellaneous stuff. You can save some bytes over the wire by saying, just give me the headers. Maybe I just want to aggregate these things and count them up, and I don't need the payloads. I just need the messages and their headers. Sampling is great for being able to admit some stuff for monitoring purposes. We won't cover that today. Just like streams, consumers can also have metadata, so you can build better tooling around it, or you can kind of just set metadata for your own kind of labeling and organization purposes. And an active threshold we covered very briefly, but this has to do with whether or not, whether it's an ephemeral consumer or a durable, when should the server clean that up when the server has detected any sort of inactivity or clients that have not bound themselves to this particular consumer. And those are really all of the settings. There might be some minor ones that I'm missing here, but this is an overall explanation of everything in the consumer config, which I know when we first look at it, it can be like super, super overwhelming. But if you go through this video and you go through these explanations, hopefully you should walk away with a much better kind of mental model of how all of these consumers work. And the fact that if it's looking overwhelming, it's there because it's flexible. In fact, it's way more powerful than all of the alternatives to NATS in this regard. And let's go ahead and dive into some code to show how that flexibility really manifests itself. So going back to our very first slide here in the stream, let's kind of cover the use case of this event sourcing consumer, because I think this is kind of the more common pattern. We might not be as strict, but it's really kind of the common pattern for a consumer, where it might just be a queue of things that we want to process in a particular order, or just make sure that we have a lot of guarantees around how those things have been delivered. So let's go ahead and write a consumer that does some of this event sourcing. And I'll also kind of show you how this max Ack pending really kind of plays a role in the performance of this particular consumer. So I have a little bit of code up right now. This is all really just boilerplate, just setting up my my NATS. It's connecting to NATS, creating a new JetStream, and then it's calling out to this event sourcing consumer function, and then shutting down. And so this event sourcing consumer function is actually what we're going to be dealing with today. So let's go ahead and start writing that. First thing we're going to do is we're just going to create a little context via the context package. We'll just use the background context. This is because, This is because the new JetStream package really makes use of the Golang context package, which is great, can handle like cancellations and timeouts and everything like that a lot more easily. And then we're going to go ahead and create our consumer. We're going to do this by saying JS dot
create or update consumer. We're going to pass in our context that we just made, and then we're going to pass in a JetStream config. There we go, JetStream consumer config. And like I said, if you just went and filled out all of these fields, you would get super overwhelmed because there's so many options. But you know, we just went over all of these options, and we're not going to use all of them. We're only going to be using a few of them for this particular thing. So let's start with name and durable. Let's just call this event sourcing. This is going to be our event sourcing consumer. And imagine that we're binding to that orders stream that I do have, it's live. And we want to just process each and every one of those orders from the beginning in order, no filtering. And we want to also make sure that we're doing so in order. So we're going to set our max Ack pending to 1. That way we don't attempt to deliver any new messages. And so if anything fails, and tries to redeliver, it's going to be doing so in the case that like it's only sending out one message at a time. And like I said, this is going to be extremely slow. And so it might not be for everybody. To be honest, I would actually recommend trying to see if you can get away without having a max Ack pending of 1, and seeing if you have ways to kind of reconcile ordering, because it's going to be much faster to do it that way. The kind of rule of thumb that I use, by the way, when it comes to like having to reconcile ordering is like a lot of people think that they need ordering, but often what is the case is I see that they're kind of pulling in events and they're just putting them in a database. Like if you're pulling an event and putting it into like a SQL database where timestamps are indexed and there's no kind of like insertion assumption about that particular data, you don't need ordering. Like you could just insert that stuff. But if you do need ordering, let's say you're running a state machine on the other end that's making decisions and you need absolutely explicit ordering on that end, then that's when you're going to want to kind of use a max Ack pending of 1. But I'll show you kind of the performance differences between the two in just a sec. So we'll set max Ack pending to 1, and then we're not going to filter on anything. In fact, this is going to be our entire configuration for this particular consumer. So looks like we're missing one other thing. Oh, we need to pick the stream, which is our second argument. So our stream is going to be called orders. And just to show you guys what the order stream looks like, I'm going to go NATS stream info orders. We can see that this stream has 31,620 messages. And if I just do a quick NATS stream or NATS sub stream orders, it's going to pull in all of those messages. This has actually created an ephemeral consumer for me, which is cool. And you can see that we have, orders that are delivered, some are processed, some are shipped, but we have them kind of broken up by order ID, by the location. So there's a lot of different ways we could slice and dice this. Back over to our consumer. Now that we've picked our orders consumer and we've set our JetStream config, we can now check for an error and start consuming from this consumer. So I can I'm going to return consumer.consume. We're going to use this consume method, pass in the context. Do we need a context? No, we just need a handler. We're going to pass in a handler. So this just takes a JetStream message, and it's going to basically just give us one message at a time. And so we want to make sure that we acknowledge this message. And I'm going to do a couple things here. I'm going to pull out the metadata for this particular message. And if there's an error, we should just kind of, print it and move on. I'm going to say, sure, and then we'll return. I'll just make that a log. Okay, so we have our metadata, and now I kind of just want to print out, the fact that we've received our message. So I'm going to go ahead and say, let's see, log.println. I'm going to say processing message. And I'm going to give the message metadata. So I'm going to say meta.sequence, and I'm going to choose the consumer sequence. And this is going to show me, bound to this particular consumer, kind of what message have we processed. And this is going to show us that we're now processing these messages in order. So it's going to start at 1 and continue on from there. I'm also just going to print out the message subject, just so we kind of have an idea of how things are chugging along. We'll acknowledge it. And then we're done. That's pretty much everything that we need for this event sourcing consumer. So let's go ahead and try it out. I'm going to say go run main.go.
And you could see that we started with message 1 and we're processing them one by one. Now, my computer is going back and forth to Synthia Cloud, so that's going to introduce some latency. Maybe if this was closer, it would process a lot quicker. But as you could see, because we are processing messages one by one and we are acknowledging them one by one, it's going to be kind of slow going from here, which could be totally fine if we're operating kind of like in a state machine. But if we need this to go faster, there's some options here. So we can either, maintain complete ordering here and scale these out via partitioning. That's going to be a completely different topic for a completely different video. Or we could certainly turn max ack pending off if we decided that we don't need that guaranteed ordering. So let's go ahead and show you what this performance looks like when we turn max ack pending off. Just going to comment it out. Let's go ahead and run this. And because this is a durable, it's actually going to pick back up where it left off. Now, because we have this max ack pending, set at the default, and we're acknowledging things kind of, not fully in batches. We're still acknowledging them one by one, but we're doing so asynchronously and moving on when we can kind of see that we're processing this stuff much, much faster. And this is, this is all happening with still individual acknowledgements on messages. And now we've processed the entire batch of 31,000 messages. We are all caught up. And so you can kind of see the major performance differences between doing strict guaranteed ordering versus, hey, I'm okay if stuff gets redelivered a little bit out of order because of how I'm storing things on the other end. Reporting is quite different from event sourcing in the sense where we're going to want to have an ephemeral consumer. We're going to want to set ack to all or none because we really don't care about individual acknowledgements here. We don't need those sort of guarantees. And we want to set a start time. I'll probably set it to like 7 days ago. We could also say maybe because we're aggregating these things in counts, like we only want headers. And so we're going to make this as fast as we possibly can to get all of this data. So we really want to answer the question, hey, how many orders in the US shipped within the last 7 days? So let's go ahead and write that. What did we call this? I called this reporting consumer. So I'm just going to go ahead and copy my event sourcing consumer, and I'm just going to rename it reporting consumer. Okay. We'll keep a lot of this the same, but I'm just going to call this reporting. And I'm not going to make it durable. This is going to be an ephemeral consumer. One thing that you could do for ephemeral consumers is if you're going to be developing this and you're kind of shutting it down and bringing it back up, and you bring it back up too quick, it's actually going to take the ephemeral consumer that you just bound to, which could be wanted behavior. So we keep ephemeral consumers around just for a little bit because we know that there's network jitter and sometimes things go online and then quickly back, or offline and then quickly back online. But if you don't want that behavior, you can put a little bit of randomness inside of your name. So you can have, every time you boot up a fresh instance, it's going to be pulling in a new or creating a new ephemeral consumer there. You can also use the create consumer method here, and that will obviously error out if there's any particular conflicts with naming. Okay, so what we want to do with this ephemeral consumer called reporting is quite a bit different than what we did inside of the event sourcing one. So we want to say headers only just to save some bytes over the wire. We're also going to say max batch request. Max request batch. We're going to bump this up to 1,000. And this means when it goes to fetch things, it's going to be like, hey, give me up to 1,000 messages here. This is just going to make getting messages much, much quicker. I'm going to set the Ack policy to Ack none. Let's see, Ack none policy. Because we don't need any acknowledgements for this particular reporting thing. We're going to set the delivery policy to deliver by start time. So we're going to say JetStream deliver by start time policy, and then we need to set which start time we want, which is going to be with the opt start time. And we need to actually create a time here. So I'm going to say T is time. We'll import the time package, and we'll say for 7 days. So we're subtracting 7 days from time.now. So we're saying 7 days, starting from 7 days ago. And this needs to be like that. There we go. And lastly, we want to filter on a particular subject. So I'm going to add my filter subjects here. And this is going to be a string. You could actually pass multiple filter subjects. This is new in a recent version of NATS server. We can actually pass in multiple, subjects here. So if for some reason I wanted like all of the orders in the US that have been shipped
and all the orders in Canada as well, I can also do that, which is just superb. I love that you're able to do something like this. But for now, we're going to say, give me all the orders in the US that shipped within the last 7 days. And that's what it should give us in a very, very efficient way. So let's go ahead and try this out and see if it works the way that we hope. Before we do that, I'm going to remove that acknowledgement because we don't need to be sending acks. And let's see how all of this stuff works. Oh, before we do, I forgot to enable this at the top. So we'll enable our reporting consumer, disable our event sourcing consumer. Let's go ahead and run this and see what it does. All right, so we've already processed all of our messages, which is great. Just a reminder that this is also just coming from Synadia Cloud itself. And so maybe you're running a front end where you're doing some reporting and you want to be like, give me all of the orders that, shipped in the US within the last 7 days. And it gave me all 1,620 of them. Is this going to be as fast as a SQL query if you're doing aggregation and you want to do the count on that side? No, it won't be, but it's very versatile and you can express a lot of things without having to move all this stuff into a separate data store. And so for ad hoc queries and for being able to kind of do stuff like this is a pretty good solution. The other thing I want to mention is that this isn't just a query, but this is also going to give me any new, newly shipped orders that come in via the US. So you can kind of keep this around and have a live view around it. So a lot of really interesting things that you could build with a structure like this. Okay. We're on to our last example, so let's kind of take a look at what that one looks like. Our last example is lookup, meaning let's say I just did the reporting feature and it gave me all of the shipped orders, and now I want to kind of double click on an order, look at its ID, and basically give me all of the statuses that order has had. So we're going to be using a couple different configuration settings to do this in a really efficient way. So starting with the filter, we're going to make it an ephemeral consumer, no acks, and we're going to use last per subject instead of time here. It might not be as applicable to this one, but let's say that you're doing any sort of change data capture, last per subject comes in clutch as a option here. So let's go ahead and make our lookup consumer. I'm going to start by just enabling our lookup consumer here, and I'll copy our reporting consumer, and I'll just call this one lookup consumer. We don't need the time. We're going to set our deliver policy to deliver last per subject policy. We'll remove kind of max batch and headers only. Maybe we want the payload here, and I'm going to call this our lookup. And instead of looking at all the shipped US orders, I actually want to just look up a order based off of its ID, which is this token right here. And I'm going to go ahead and copy this token and paste it in right here. This is an order that I know has some statuses to it. And this is just an example. We can, of course, insert this dynamically if we wanted to in our code. But then this is a consumer setup that should give us, in a very efficient way, kind of the messages related to this order, and it's going to deliver last per subject. Now, let me show you something really cool. Is we could actually use deliver last as well if we just wanted the last status update for this particular order. So if we want to know, hey, I have this order number and I want to know whether it's been shipped or whether it's whether it's been delivered or whether it's currently processing, things like that, we can use this. So I'm going to say go run main.go, and you can see it's only going to give us one message. But it's also going to be kind of hanging on to see if there's any new status updates here. But we know that this has been delivered. So if maybe you're running an e-commerce place and you need to look up the last status, you can do that by creating this ephemeral consumer. Now, an even more efficient way to do that, and something we'll cover in another episode, is we could actually use the direct get API call to do this, especially if you just need that one message. In future versions of the NATS server, we're actually introducing a batch version of the direct get API call that allows you to do a lot of the things that we're doing today, but through a single API call and no having to create a consumer. So it's going to be even faster to get at that particular set of data. Now, back to the last per subject, we could put this in here, and this is going to give us all of the statuses in order that they were received for this particular order. And there we go. We know that
this order was pending, we have a timestamp for it, then it was confirmed, then it was shipped, and then it was delivered. So if you need to kind of like look up an order and show its like life cycle, you can do that very, very easily by creating a consumer like this. Once again, we should be able to do this in the future with just a single JetStream API call, like a request reply. And that's going to be glorious when we can, and I'll make a video about it when it's time. But that pretty much covers all of the examples here. Like I said before, all of this code is going to be available via GitHub, the presentation available via GitHub, and so I'll include a link below. But as always, thank you so much for watching. I hope you enjoyed this content, and if you do have any suggestions for content that you'd like to see in the future, be sure to comment down below, and we'll put that in our backlog. It's always fun being able to explore NATS and JetStream with you all. So everybody have a great day, and I'll see you next time.